back. So in previous lecture we discussed about the different stages and the associated landforms one can see in different areas, that is youth, mature and old. Now if you come down to this figure, which shows that in the uplands what you see is the narrow valleys, whereas in the central part you find, as you move towards the mouth, you have broader valleys comparatively and then much broader valley at the end. And also this shows the width and the discharge with respect to the different locations, that is A, B and C. So you have the velocity, one is width, discharge, relationship between depth, discharge, valley, discharge and gradient discharge. So basically what it shows us that the gradient decreases as you move towards the mouth, and the discharge comparatively, the velocity comparatively increases as the discharge increases, whereas the depth also increases along with the discharge and the width also increases along with the increase in the discharge. So change is downstream if you look at. So in the upstream channel, depths are shallow, though steep slope, the discharge is low, less cross sectional area. So what we were looking at, the V-shaped valleys. The stream bed causes much more resistance to the flow of shallow water. Discharge increases downstream as each tributaries, that is a stream, smaller streams joining the larger streams, introduce more water, and of course along with that you will have the bed load also. To accommodate the greater volume of water, velocity increases together with the cross sectional area of the stream. This is what you see in the downstream. So the channel pattern varies from upstream to downstream, and we also discussed about the different landforms starting from V-shaped valleys, narrow gorges, up to the broad valleys in the deltaic plains, and that what we were talking about, the old stage close to the mouth. In the medial part we have mature stage, and in the upstream area we have the youth state. Now channel pattern further, if you take into consideration, this has been classified based on the sediment load, which has been shown here. So you have suspended, mixed and bed load. So channel classification based on pattern, type of sediment load, showing type of channels, their relative stability and some associated variables. This is after Schumm, which talks about that how the pattern will change with respect to the bed load and all that. So 5 basic channel pattern exist. This we will also talk when we are talking about tectonic geomorphology. So there also this channel patterns plays an important role, but in general what we see is the 5 basic channel patterns. Straight channels with either migrating bars, pattern 1, pattern 2 is migrating alternate bars. Again this is the straight channel, but it is in the form of the mixed bed load. So 2 typical sinus channels, 3A and 3B, where you have a highly sinus channel pattern 3A with equal width throughout the sinus channel. So, you have equal width of the channel, whereas 3B the channel width varies. So, a channel with a wider at the bends, so it becomes wider at the bends. This is the channel 3B, and then you have 4A, which is meander braided transition. So, this is the 4, and then that this what you enter into the bed load and typical braided channel. So, you have total bed load in this pattern. So, you have typically the braided streams. So, river exhibits various channel patterns that can be related to variation in water discharge, variation in sediment load, presence of bedrock, outcrop, human influence, tectonic influence. So, these are all important aspects which can play an important role in changing the channel pattern from straight to braided. So, this is what has been shown here, that the straight channel are highly stable, whereas the braided channel which have the bed load the stability is very low. So, this you keep in mind, that the channel pattern varies from straight to braided, and they are influenced. One is variation of discharge or water discharge, variation in sediment load. So, if the sediment load increases, the channel pattern changes. Presence of bedrock, human influence, and tectonic influence. Now, along with this, another important aspect which will affect the change in channel pattern is the slope. So, one is the gentle slope, and another you have the steeper slope. So, change in the slope will also affect the channel pattern, and as the change in the channel slope eventually will result into the change in the discharge, that is velocity also, and velocity will affect the erodibility, and the erodibility will result into the pouring of more sediments. So, sediment bed load will change, hence the pattern will change. So, this is all interconnected. So, this is important, which you can remember, and this figure also talks about the similar type of the channel patterns. This is also after Schumm. So, you have from suspended bed load or suspended load to the bed load. So, you have from straight to the meander, and then bed load you have the channel which is straight bars, whereas here from anastomosing to braided. And this channel pattern we will discuss later, but basically if there is a change in the slope, then the channel pattern will change from sinus to anastomosing, or you have single braided channel to branching channel, or what you see here. So, multiple meandering channel from meandering channel, and single straight channel to island chain channels. Okay. So, these are the few examples which also you will come across. Now, coming to the very basic thing, that different type of streams what we usually come across, and this is based on the surface geology and the slope which we can classify. One is the consequent stream. So, consequent stream, a stream flows or follows the slope basically, or flows over the sloping surface. So, they had been termed as the consequent stream, and such slopes could be natural or tectonic slopes, are formed because of the ongoing deformation. So the stream follows the slope developed on development of, or stream follows the slope. The development of slope could be because of the sudden uplift. Then comes to the subsequent stream. Subsequent streams that develops later on, carving the softer rocks and flows at almost right angle to the original slope of the land. Now, when we say almost right angle, then they are flowing over the folded terrain. So, the folded beds, if you have, and which are eroded, the softer rocks are eroded away. So, either they follow the synclinal area or they erode the crust part of the fold. Then you can say that, okay, fine, these are all subsequent stream. They are not exactly following the slope, but they are against the slope. Then we have the antecedent stream. Antecedent streams are mostly those streams which cut across the folded belts. So, most of the streams which are crossing Himalayas are antecedent stream, because the folded mountain chain, they incise the folded mountain chain and flow across them. They are termed as antecedent stream. Then come the superposed streams, where what you see is that they flows across the different lithology and structure. So, what we see here is the unconformity between the inclined beds here and the horizontal bed here. So, they are flowing across the different lithology and structure. So, these are been termed as superposed streams. Now, stream piracy is nothing but the capturing of the river system or the basin. So, it can happen through headward erosion, because the most of the, or mostly the drainages are, the extension of the drainage basin is because of the headward erosion. So, through rapid headward erosion, a stream may breach a divide intersecting another channel and capturing its flow, or stream capture is the interception and diversion of one stream by another stream that is extending its basin by erosion in the headward direction. So, the diversion of flow into new channel may leave a vein gap along a ridge. This is very common where the erosion is intense. So, stream piracy, if you look at in this sketch, it has been shown that, for example, you have an uplift which is going on here. So, you have a drainage divide where the drainages are flowing in opposite direction, but slowly, because of the extensive erosion, both the drainage are evolving and moving towards the headward side. So, this drainage is moving towards headward here, and this is moving towards, and finally, at one point of time, because of the divide breach, this capturing can take place, and whole system or the drainage basin which was pouring the water towards this basin will finally contribute to this river basin. So, this is an example which is because of the drainage breach, divide breach, and river capturing phenomena can take place and result into the extension of drainage basin. So, this has also been termed as stream piracy. Drainage pattern. So, now we are moving into a new topic where we are going to talk about the drainage pattern. So, until now we have discussed about the channel pattern. So, meandering, straight, braided, anastomosing, anabranching, these are all channel pattern. So, now we are going to talk about the drainage pattern, and drainage pattern, as I told in the beginning also, that it is controlled or is the manifestation of the subsurface geology. So, let us see. So, the geometry of stream network in a region that reflects aspect of underlying geology. This is the shaded relief map of northwest Himalaya, where you can see the youngest mountain chain and multiple folded ranges across this line, which starts from the Shivaliks, youngest mountain chain in Himalaya, and contact between the two plates. This is Indo-Gangetic plain area, and this is the plate boundary, which is marked by the rising hills of Himalaya. Two rivers which are debouching into the Indo-Gangetic plain, the major river Sutlej and Bias. They are the major rivers which are debouching into the Indo-Gangetic plain. Again, both of them are antecedent streams, and even they have cut through they are flowing through the folded mountain chains here. So, they are all antecedent stream. Now, what is important about drainage pattern we are going to talk here is that if you carefully see, then we have some sort of features which are developed on the surface of fold here. This is a longitudinal fold. So, this is the strike of the fold, or the fold axis is in the center, and the drainages are flowing on either direction. Now, I am on the different directions. So, what we did was that this is based on the digital elevation model, we extracted the drainage of this area. But before going to that figure, if you see, this is a 3D prospective view of the terrain, which shows the contact between the Indo-Gangetic plain, the Sutlej river coming out, and Bias river over here, and this is the youngest mountain chain in this region. And then what you see here is devoid of some drainage, but the slope of in this area and this area is in this direction as well as on the opposite direction. So, what we did was that this is again another photograph, satellite photograph, which shows the drainage which are developed here. So, this is an example of parallel drainage or drainage which are formed on the sloping surface. So, consequent drainage are developed here, and then we have the channel which have been or the drainage which are formed here, and very fine drainage we can say, because many tributaries are there. So, this is also showing a different pattern, whereas here also this is a different pattern of the channel of the drainage pattern basically. So, again we have the Indo-Gangetic plain, the Himalayan front here. Now, what we did was that we extracted the drainage from the digital elevation model, and what you see here is the darker thicker line is the main stream, which is the trunk stream, and then the smaller tributaries are joining. So, this is the tributary which joins the Sutlej river, and these are the tributaries which are joining the Sutlej river. Similarly, this is one tributary which joins the Bias river. So, Bias river originates in the higher Himalayas, as well as Sutlej originates in the higher Himalayas, flow across the mountain belts and debouch into the Indo-Gangetic plain. And as I was talking about that, there is the frontal fold. So, if you take only this example, what it shows is this is the demarcation line, and this is the divide or the ridge line which separates the two drainages on either side. So, one is flowing in this direction, other flowing is this the other direction, and this is the ridge line or the drainage divide. And even the smaller drainage divide you can mark here in this area. So, major streams which are flowing and shown by the darker blue lines, and the smaller one or the tributaries which are flowing and joining the major trunk stream. Similarly, over here if you see, this area is again an important one, which we will go back and see the 3D prospective view. The drainages are flowing in all directions. Once the drainage is coming out here, flowing in this direction, drainage flowing in this direction, drainage flowing in this direction, and this direction. So what does this indicate? That the central portion is a bulged area. So if you look at the previous slide, then you will realize that this region is slightly warped area. So if you see here, this area, what we were looking in the drainage base, the drainages which are flowing in all directions. So this is another example of the uplifted or the domal area which was identified in the uplands or close to the higher Himalayan region. So this is everything will be reflected. So even the geology and the structures which are present, geological structure present beneath or subsurface, based on that the drainage will be formed, the drainage pattern will form. So in most commonly found drainages are dendritic drainage, then you have radial drainage, rectangular drainage, and trellis drainage. And how they are classified we can see easily. This is monotonous homogeneous geology. If you have, then you will be able to see the dendritic drainage, whereas the radial drainages, if you are having domal structures, as we were looking in the previous slide. So if you are having the elevated portion in the center and sloping surfaces on either side, will result into the formation of radial drainages. If you are having the fractured rocks, and if you are having a high angle or maybe the fractures at almost right angle, then you will be able to see the rectangular drainages. And trellis drainages are formed where you have the flow which goes across, or the drainage which flows across the folded mountains or the folded terrain, and the tributaries flows along the longitudinal strike of the fold and joins almost at right angle. So valley cut in less resistance rocks will be seen as the tributaries which are flowing almost perpendicular, and then main trunk stream will be flowing across the ridges or the folded ridges. So this is what we did, and we also the investigation along the Son Dune. This is an area which is close to the Chandigarh city here, and again the Landsat shows the folded mountains across the Himalayas. So this region we surveyed, and what we found was that there is again this we never visited in the field, but based on the drainage, when we identified the fold here, which was not expected, but based on the drainage we were able to easily identify. The drainage has been flowing in all direction here. So now if you look at this area, which is occupied by the region is occupied by the Shivalik succession as well as the younger quaternary succession. So this is the terrain, the succession which is occupied by the terrain, and the close up, if you look at this area which I was showing in the previous slide, the drainage is flowing on either direction. So this portion is a warped portion, which is because of the fault line which is marked by the arrows here. So this fault along with the deformation has been taking place, resulting into the warping of this area. So this was a very young deformational feature which we identified, and let us see the field diagram of this, or the field photograph of this. What we were able to find is the sloping surface. So this is the central portion is elevated, and on the right bank of river, what we found Chinky river. So this is the field example or the field expression of the radial drainage which we saw. Now the further, if you look at the drainage pattern, then we have several such drainage pattern which is mainly the reflection of the subsurface geology and structure and slope in the in subsurface. So, mainly the geology and the geological structure plays an important role in the manifestation of the drainage pattern on the surface. So, you have dendritic pattern, you have parallel pattern, trellis pattern, radial, centrifugal, centripetal, distributary, rectangular and annular. So, these are the list which have been given of the different drainage type and the description. Like for example, if you are talking about the dendritic pattern, then what it shows us that it is an irregular branching of stream, haphazard resembles tree, homogeneous material, crystalline rock, horizontal beds. So, mainly the geological structures what you will be able to see are been listed here, and gentler slope. Subdendritic, slightly elongated pattern, minus structural control will be seen, and then so on. We see few of these channels, but please go through this table. This will be important and you will be able to remember. For example, we were talking about the parallel drainages in one of the slide from the Himalayan region. So, channel running nearly parallel to each other. So, parallel drainages are mostly the channel runs parallel to or flows parallel to each other, and they are developed along the steep slope. Now, this slope could be because of the natural or tectonic slope also. Then trellis pattern, the main stream runs parallel or minor tributaries joins from the stream. So, this is the flowing across the folded sedimentary terrain. Radial, as we were looking at the previous example. So, we will have the domal areas or the residual erosional features, or due to deformation we have the warping. So, two examples we saw of radial pattern also, one from higher Himalayas from Kangra Valley, which I was showing in 3D perspective view, and another one close to the river which is close to Nalagarh, that was been shown in the previous slide. So, I will stop here and we will continue in the next lecture and see some details about this, as well as talk about some flood related hazard in this topic and the importance of the drainage network. Thank you so much.